and then the author of Seeing the Anatomy of Quantum Gravity Through Formula. The two research publications on peer-reviewed journals, and with them we have, the unification of quantum mechanics to classical mechanics. So now in this live session, Terence on the beauty of mathematics in describing the reality of give my own opinion, and then I'm going to suggest the current formula that we have, which is the most beautiful formula presently. So now let's enjoy the interview, the video together. Okay.
What to you is the most beautiful or elegant equation to in beauty is the simplicity. So if you look at E equals MC squared, so when a few concepts come together, that's why the Euler identity is often considered mathematics
between different things that so if you e to the pi I equals -1. So yeah, people use all the fundamental constants. Okay, that's cute. But to me, so the exponential function was introduced by Euler to measure exponential growth. So compound interest or decay, or anything which is continuously growing, continuously decreasing, growth and decay or dilation or contraction is modeled by the exponential function. Whereas pi comes around from circles and rotation. If you want to rotate a needle, for example, 180 degrees, you need to rotate by pi radians. And I, complex numbers, represents the swapping between real and imaginary axes, so a 90-degree rotation, so a change in direction. So the exponential function represents growth and decay in the direction that you already are. When you stick an I in the exponential, it's instead of motion in the same direction as your current position, it's motion at right angles to your current position, so rotation. And then so e to the pi equals -1 tells you that if you rotate for time pi, you end up at the other direction. So it unifies geometry through dilation and exponential growth, or dynamics, through this act of complexification, rotation by I. So it connects together all these tools of mathematics. Dynamics, geometry, and the complex numbers, they're all considered almost, they're all next door neighbors in mathematics because of this identity.
Do you think the thing you mentioned is cute, the collision of notations from these disparate fields is just a frivolous side effect, or do you think there is legitimate value in when the notation, our old friends come together in
right.
unite?
Well, it's confirmation that you have the right concepts. So when you first study anything, you have to measure things and give them names. And initially, sometimes because your model is again too far off from reality, you give the wrong things the best names, and you only find out later what's really important.
Physicists can do this sometimes. I mean, but it turns out okay.
So actually, with physics, so E equals MC squared. Okay, so one of the big things was the E. Right. So when Aristotle first came up with his laws of motion, and then Galileo and Newton and so forth, they saw the things they could measure. They could measure mass and acceleration and force and so forth. And so Newtonian mechanics, for example, F equals ma was the famous Newton's second law of motion. So those were the primary objects. So they gave them the central building in the theory. It was only later, after people started analyzing these equations, that there always seemed to be these quantities that were conserved. So in particular, momentum and energy. And it's not obvious that things happen in energy. It's not something you can directly measure the same way you can measure mass and velocity, and so forth. But over time, people realized that this was actually a really fundamental concept. Hamilton, eventually in the 19th century, reformulated Newton's laws of physics into what's called Hamiltonian mechanics, where the energy, which is now called the Hamiltonian, was the dominant object. Once you know how to measure the Hamiltonian of any system, you can describe completely the dynamics, what happens to all the states. It really was a central actor, which was not obvious initially. And this helped actually, this change of perspective really helped when quantum mechanics came along. Because the early physicists who study quantum mechanics, they had a lot of trouble trying to adapt their Newtonian thinking, because everything was a particle and so forth, to quantum mechanics, because everything was a wave. It just looked really, really weird. Like you ask, what is the quantum version of F equals ma? And it's really, really hard to give an answer to that. But it turns out that the Hamiltonian, which was so secretly behind the scenes in classical mechanics, also is the key object in quantum mechanics. That there's also an object called a Hamiltonian. It's a different type of object. It's what's called an operator rather than a function. But again, once you specify it, you specify the entire dynamics. So there's something called Schrodinger's equation that tells you exactly how quantum systems evolve once you have a Hamiltonian. So side by side, they look completely different objects. Like so one involves particles, one involves waves, and so forth. But with this centrality, you could start actually transferring a lot of intuition and facts from classical mechanics to quantum mechanics. So, for example, in classical mechanics, there's this thing called Noether's theorem. Every time there's a symmetry in a physical system, there is a conservation law. So the laws of physics are translation invariant. Like if I move 10 steps to the left, I experience the same laws of physics as if I was here. And turn around by some angle, again, I experience the same laws of physics. This corresponds to the conservation of angular momentum. If I wait for 10 minutes, I still have the same laws of physics. So there's time translation invariance. This corresponds to the law of conservation of energy. So there's this fundamental connection between symmetry and conservation. And that's also true in quantum mechanics, even though the equations are completely different. But because they're both coming from the Hamiltonian controls everything. Every time the Hamiltonian has a symmetry, the equations will have a conservation law. So it's once you have the right language, it actually makes things a lot cleaner. One of the problems why we can't unify quantum mechanics and general relativity yet, we haven't figured out what the fundamental objects are. Like, for example, we have to give up the notion of space and time being these almost Euclidean type spaces, and it has to be, we kind of know that at very tiny scales, there's going to be quantum fluctuations. There's a space-time foam, and trying to use Cartesian coordinates x, y, z is going to be it's a non-starter. But we don't know what to replace it with. We don't actually have the mathematical concepts, the analog of the Hamiltonian that sort of organized everything.
Okay. Good. Okay, so now that's it. It is now time for my own opinion on that video. So I wish to use this image, in explaining some of those things that Terence mentioned in that interview. First of all, he made mention of the Euler's equation, you understand, which is e to the I pi plus 1 equals 0. That equation right there, when you take plus 1 to other side, you have minus 1. So now the first thing, he made mention of the exponential function. Now he said exponential function deals with growth, and then as well deals with decay. Yes, because when you have exponential function such that you have expansion, you're actually having growth in that sense, and there is a part when you have negative value. So that is the contracting phase where you have decay. So that is what Terence was trying to say in that particular interview. So now we can see that to him, the beauty of that equation is for the fact that the equation could, combine so many things to try and, model the reality of our universe. So he said that the pi, deals with the rotation of a circle, And then the I that we have there, which is an imaginary number, it has to do with, change of direction. Basically what it was trying to say there and talking about. So anytime you have imaginary number, you know that as you try to, solve it further, you usually get the flipping of I to real integer. It could be negative integer, then plus integer. You usually have that flipping pattern in the I. You understand? And that is what it was trying to say right there. So because of the fact that the equation could combine so many things to describe reality of the universe, to him, that is why the equation is the most beautiful equation. So people tend to attach that beauty to something that is so simple. So you understand? And people have been saying that E equal MC square should be the most simple equation, and so it should be the most beautiful. But now to him, that is not the most beautiful. The most beautiful is that Euler equation. Symmetry rather. He made mention of symmetry and how that is related to conservation. You understand? So, and then he finally talked about the divergent phenomenon that we have in the universe, such that scientists like the mainstream scientists could not unify quantum mechanics to classical mechanics. Okay, that is just the summary of the whole video. So now, if you look at this image that I have right here, I've even used this image in one of my videos, but basically this image is ideal for this purpose, and that is why I'm using it again. Now, I want to tell you that in time to come, in due time, formula of everything is going to be the most beautiful formula. It's going to be the most beautiful formula, if not the most beautiful formula of all time. Because here in this review, we'll get to see how this formula is able to, model the entirety of the universe, the entirety of the universe, and even the whole mechanics of the whole universe, and then the reality of the universe. We'll be able to see it. And when you look at the formula is so simple. The T, the M, equal to capital UM plus 4M. At times when I call this formula so fast, I do make mistake by omitting the capital U. But right now, that is the formula. And the formula is, when you look at the formula and you dissect the formula is actually, by its analysis, will tell you, in the sense that the time, which is the T, the M, that is the curvature of time. Curvature of time wave to energy wave. And right inside the curvature of time to energy wave, we now have linear solution nested right inside it. And now the linear solution, by applying formula of everything, we have this derivation of equilateral triangle. And right inside the equilateral triangle is where we now have this conservation and even the symmetric nature of the universe. And even though we have that, like that, there is this trait of asymmetric nature right inside the equilateral triangle. And then by the trajectory of time, which is even longer than, the limit of the equilateral triangle is actually telling us that there is asymmetric solution which is embedded right inside the trajectory for us to get the reality of the universe. And even right inside the core singularity of black hole, we're still able to see this asymmetric nature embedded for us to have this quasar-like signal right from the core of singularity of black hole. So now I must tell you that this formula of everything is so powerful that it's a formula that feeds back on itself, and that feedback effect, the moment we get connected to the missing piece of electron, which is positron, we have the feedback effect, because the times trajectory, no one can traverse that trajectory 2 times. When you are traversing it the second time, it will shift reality into the future, and we have seen that in the application of formula of everything. So you only traverse that trajectory once if you want to get the exact position of positron, and getting this exact position of positron, that is the reality of the universe. So the vertical trajectory of time that we have, by the default nature of time is instant. I've been saying that. And when time is in relativistic scaling to energy, then it becomes continuous. Energy is infinite by default. Then when energy is in relativistic scaling to time, then it becomes discrete. I've been saying this. Now, by that virtue of being instant, the vertical line has to be snappy. It shouldn't be something that will be elongated, but yet we have energy elongating the trajectory in order to cover the distance, the divergence, the divergent gap. And so we're able to bridge that gap by that elongation. And by having the elongation, we now get to know that what peregrination or at event horizon is nothing but a field. So I call that field a reality field. So now, being a field, it can actually travel from the classical level down to the quantum and even beyond. So that is field for you. So now, it is ideal to have that kind of a field right at the middle, more or less like the transiting point from the field that is actually propagating outwards in the cosmological space to the field that is propagating inwards in the black hole. So there must be a point where the propagation of the expansion will actually vanish for us to have the flipped field of that contraction. You understand? So basically that is the solution, and that is the ideal solution. You understand? So now, if we're to use this image now, we have complex system right there. We still have Euler equation right here. So we have e to the I theta, and by e to the I theta is the complex wave. Right inside it we have real wave and imaginary wave. So the cosine theta is the real wave, while the I sine theta is the imaginary wave. Now we can actually extract imaginary wave from real wave, and then when you look at this wave pattern as we have it, the red wave pattern is the imaginary wave, the black wave pattern is the real wave. When you look at it towards the right, you can see that when the black wave pattern reaches the central point, then imaginary wave is at its maximum energy. With that, I now say that imaginary wave is an energy reservoir for real energy at the point of exhaustion. Okay, the reason I said that is for the fact that when you apply formula of everything, at that present phase, energy is at low energy state. At quantum level, energy is at low energy state. And we realize that the moment we get connected to the positron, such that the positron is then injected into the system, then we have this energy energized phase to propel momentum into the black hole. So energy, extra energy is needed at that phase for further propelling into the black hole. And that is why I could say imaginary energy is more or less like a reserved energy for real energy when that real energy is exhausted. So now, like Terence said in that interview, when we get the right interpretation, then we get to understand that mathematics is the language, is the language in which the whole universe is written. So if we can get right interpretation, then we know that if we can get to know what each mathematical notation can do, what it is meant for, which, what each number, what each equation can actually do, then we'll be able to model universe quite all right. So now, I must say, by God's grace, I thank God for the inspiration to have, to have developed this particular formula of everything. And with that formula, we can actually, get the reality of the universe. And so now, we have equilateral triangle. So the equilateral triangle of the expanding cosmology, of the expanding cosmological space, is different from the contracting black hole phase. You understand? So now we have the flipping mechanism right substrate dimension, because the moment we have that trajectory out of the time energy wave of the substrate dimension, which is 2D, then it gets connected to the 3D. We know at the point of curvature of mass convergence to the curvature of energy, we're going to have standing wave. Standing wave is a kind of static canundulating wave, similar to the field that I was able to discover by applying formula of everything. So any kind of wave that you can have which is not directional is a standing wave. So once you have standing wave, we can get connected to the higher dimension. So that standing wave is more or less like a product of that static and undulating field that I have discovered. And right through the static and undulating field, we could have instant, transmission of information. So now, by that application of formula of everything, then I get to know that quantum entanglement is actually between, quantum mechanics to the complex system. So it's actually beyond the constraint of quantum level. And that is why we could have instant transmission of information via quantum entanglement. So now there are 4 things to consider when by having this equilateral triangle system and then time energy wave model. Number 1, 2D to 3D transition. We have this connection between the substrate, which is 2D in this case, and then the higher dimension, which is 3D. And then I've been saying it that for a substrate dimension to be fully for substrate dimension to fully realize its full potential, it must get connected to the higher dimension. And so in one of my videos I cited a particular example that if you have an ant on one side of a plain paper that is being placed on the ground, then that ant will not be able to cross to the other side. And by not being able to cross to the other side of that paper, then the ant will not be able to explore the entirety of the 2D. So if you can lift up that paper off the ground, then the ant will be able to cross the border, the boundary, and then explore the other side. So that is when the ant can actually explore the entirety of that 2D. And by lifting it up, then you have taken that 2D plain paper in, lifting it up like that. Yes, so now there is this interconnectivity of dimensions. So I have a particular video on that. I titled that Interconnectivity of Dimensions. Thank you. So now, quantum entanglement, then we have flipping mechanism, which will get at the point of contact with positron. So we have that instant flipping, because what we might initially get connected to would or could rather be electron of that higher dimension, and at the point of contact it will be flipped to positron for the electron of the substrate dimension to be instantiated. So now, then what I want you to know is that we have the totality law of symmetric nature of the universe embedded in the equilateral triangle. So even though the mechanics is asymmetric by nature, because the conservation we have is for the fact that the trajectory to the quantum mechanics, which is the trajectory of energy, it decays mass work in order to support mass accumulation at classical level, and to be conserved as mass convergence at classical level. So we have conservation, we have symmetry. So now, then the fourth one is complex system integration. So by going beyond the limit of time to energy, we know the system that we have is complex system, and the moment we have that integration of positron for further momentum into the black hole, then we know that that is nothing but complex system integration. So then the whole complex system will then be the stacking of the two equilateral triangle. So definitely by stacking the two equilateral triangle, we can see the compacted equilateral triangle around the edges of the two equilateral triangles. And with that, we can get to know what the nature of nucleus is. Because by applying formula of everything, I get to know that the momentum of energy is constantly accelerated at that point of curvature. When you are negotiating curvature, a curved portion like that, then there will be these changes in speed because the momentum will be angular. Okay, so we have that, and at that point there will be a point where the energy will be continuous as well, and when that is equal to the continuous flow of time, then we have this vertical line that is being locked down for reality, and that is why the trajectory is called reality field. You understand? And then it is essential for us to have this global now for us to get reality of the universe. So that is the mystery of the universe that we have through the application of formula of everything. So now let's go through how the formula of everything is often applied. So application of formula of everything, FOE, the T, the M, capital equal to capital U. If you want to know how this formula is derived, you can, get the time theory of the universe. The time theory of the universe, there I derived this formula. When you get a copy of that research publication on that peer-reviewed journal, so you can see how the formula is derived right there. So now if we should put the value of our electron right in the place of this M and this M, we're going to have what we have under the first result phase. And by solving that, we have this value as our classical mass, which is 2,277,250,000 kilograms. That is the classical mass. So now, if we should put the classical mass right inside the formula, such as if we should put that right inside the formula for us to reconfirm the electron's mass, we know we can't reconfirm the electron's mass because the trajectory is one-way traffic. Just like I said that the time trajectory is one-way traffic. You understand? So now by solving this, we have this particular value in power. I want you to take note of how we usually have, this value of power and just normal base value. When the classical mass worth was gotten, there is no power attached to it. So we have it in form of 2,277,250,000 kilograms. But the moment we supply that value, we now get a value of power, which has 5.7 times 10, which has 5.7 times 10 as its base. 5.7 as its base times 10 raised power 48. Now we have power right there. Now the reason we have this is that we are in that phase of expansion, because don't forget that exponential function, just like Terence said, deals with growth and decay. Now you see that anytime we now want to deal with anything that has to do with expansion, because right now we have reached that phase of expansion, and that is why we have this value of power. Now for us to know what is actually happening, we have to extend this value in standard form, and once we do that, we're going to see that the value of the weak conveying force, the value of this weak conveying force, the part where we have 4m, is being suspended at the 32nd power. You understand? It is being suspended at that 32nd position. So we have zeros as the gap of that expansion. We have zeros as the inherent gap of that expansion. So the gap will actually come right from the singularity of the Big Bang, then it will go diagonal. You understand? But now we will need to manually annihilate the suspended zeros, only the suspended zeros. And the moment we do that, it's more or less like we're going through the zero, so it will now be vertical, not diagonal again. And that will now serve as that, base of the equilateral triangle that closes that two inversely related trajectory of time and energy. So now this expansion of the zeros that we have, that will represent the trajectory of time, and by having this as an action, then there will be a reaction of that in form of the trajectory of energy. And so the annihilation will now close for us to, we close that divergent gap for us to have that equilateral triangle. So now to manually annihilate the suspended zeros, then we put this particular value. Take note that this value, there is nothing like point there. So we have it to be 9,109. So we divide that by the 10 to the power of 32, which is the power of that suspension as we have it. And then when we extend this fraction, we have it to be 9.109 times 10, 1 all over 10 raised to power minus 32. So finally, we now have that to be 9.109 times 10 raised to power minus 32 kilogram. By having the power to be minus 32, we know that the trajectory has shifted into the future. And so there is this effect of decay on it, because the power of minus 32 is smaller than the power of minus 31. You understand? So now that we have that, then if we should put this value right inside the formula, then we're going to get the decaying effect at classical level. So by putting that value, the value we now have is 277,725,000.0000003 kilogram. So that's what we have there. Shows that the classical mass worth is being decayed about almost 2 billion worth. Now the tiny decay effect of -1, the tiny decay effect of -1 has resulted to almost 2 billion decay worth at classical level. So that could be likened to this butterfly effect. Now you can see that with this formula of everything about the reality of our universe is being modeled. So now, if we should truncate the values that we have after the dot, and then supply 277,725,000 kilogram right inside the formula, we're going to get this value. And since we have power, we'll extend the worth in standard form, and then we realize that the value is being suspended at 31st position of the suspended zeros. But now this time, the base worth of that electrons or of that value is being decayed to 11109. So definitely with that, you can see that we have this asymmetric nature right there. There is this swing forth and back, which is quasar-like signal, because first of all we have that decay effect to power of -32, and then we have that, maybe I don't know, maybe I should call it decay effect or accumulation effect. So we now have that back to the power of the real electron. So you can see that swinging forth and back, and then by having the base value to be decayed like this, then it means that there is this swinging of forth and back even beneath the power. Just as we have for the power, then we also have it beneath. Now if you look at the value, the positive value of the base that we have, the remnant, I'm talking about the remnant now. Now, when we manually annihilate the suspended zeros, then we're going to have the value to be 1.1109 times 10 raised to power minus 31 kilogram. Now, we can now see that we have -1 at the power level, but we now have 1.1 at the base level. That is not symmetric. You can see it is not symmetric. If we're to have this to be symmetric, then we should have -1 at the power level, then have +1 at the base level. So now you can see that the asymmetric nature of the universe is, the virtue law of reality of the universe. So if we're to repeat this such as to have third result phase, then it will resort to infinite loops. It will resort to infinite loops. And that simply means that the trajectory, which is the horizontal trajectory, is indeed the trajectory of energy, because there we can get to the root, to the default identity of energy, which is infinite. So that is that about the old discovery. So now, based on what Terence said, he classified the Euler equation to be the most beautiful based on many things the equation could combine in order to model the reality of the universe. But now, if I'm to ask Terence this question, based on what I just explained now, which formula, or which one would he now vote for to be the most beautiful equation or formula in mathematics? So now when you look at this formula of everything, it is beautiful in the sense that the formula is simple, and not only that, it models the entirety of the universe, right from the expanding phase of the universe down to the contracting phase of the universe. So it is it deals with every detail of reality we need to know about universe. So that is why, for me, I believe formula of everything is the most beautiful formula, if not the most beautiful formula of all time. I'm not saying this because I developed the formula. I'm saying it based on what I'm able to, discover through it, you understand? So basically the research publication is right there for anyone who has interest to get and explore it further. So that is that for today's live session. Thank you for your time. So till we come together next time, I remain my humble self, Shotade Olusegun. Thank you.